Hello, everyone. This is a video that I'm recording for Public Health Community Health 3313. And what we're going to cover in this video today is we're going to introduce the chi-square test of independence. I'm going to go over the background of this slide, of this statistical test. And then what we're going to do is we're going to look at an example in R. So we'll demonstrate how to do a chi-square test in R, and we'll also show how to create a 2x2 frequency table and calculate relative frequencies based off of that 2x2 table. But first, let's get started with the chi-square test and some background. Okay, so the chi-square test, there's actually a whole family of chi-square tests, but we're going to focus on one test, which is referred to as the chi-square test of independence. We're going to use the statistical test when we want to test the relationship or association between two categorical variables. Essentially, what the chi-square test is going to allow us to do is compare proportions of categories between two groups. So we said that the chi-square test is for two categorical variables. The first categorical variable is going to be our categorical outcome. So remember that we have been looking at a lot of dichotomous outcomes in this class. And so a dichotomous outcome is a type of categorical variable. So you can use this test whenever you have a dichotomous outcome. But I want to make you aware that you could have multiple outcomes instead of just two, and it would also work. However, we're going to focus primarily on dichotomous outcomes. So some examples of dichotomous outcomes would be either, say, success or failure. Somebody could be a smoker or a non-smoker. They could have disease or not have a disease. These are all examples of continuous outcomes. So the next categorical variable that we're going to be interested in is the group variable. And so we're going to have two samples. That is, we'll have two independent groups. So we'll have another variable that defines either a disease or a no disease group. It could also describe a group that answered yes to a question or no, or we could also think of it as an intervention or a treatment group. So our first categorical variable comes from the outcome, and our second categorical variable comes from the group variable. That's how we're going to think of it in this class. So what we're going to essentially do with a chi-square test is be able to compare the proportion of those with the outcome in group 1 to the proportion of the outcome in group 2. So one important factor is how do we choose the correct statistical test? So in our course, so far, we've talked about now 4 different statistical tests as far as hypothesis tests are concerned. So the first, we've looked at one sample categorical, and that was a test for proportions. So that would be indicated in this cell. And so remember, this test for one proportion, we compare that to some hypothesized value. We've also looked at one sample test for a continuous outcome. And so for this, we did the test for one mean, where we compared that mean to some hypothesized mean value. Okay, and then in our last class period, we looked at a continuous outcome with 2 samples, and we said that we were going to compare those using a t-test. So we compared mu1 to mu2, and that was for 2 samples when we wanted to compare a continuous outcome. So then today, what we're looking at is comparing a categorical variable type, specifically a dichotomous variable, and we're going to use a chi-square test for that. And essentially, we get to compare one proportion to the proportion in another group. All right, so the first step that we do is we need to make sure we understand what the null and alternative hypothesis are for the chi-square test. I think that the easiest way of writing the null and alternative hypothesis is what follows on the screen. So the easiest way for the null hypothesis is to say that there is no association between x and y. Well, what is x and y? Here, we're letting x represent the first categorical variable of interest. Generally, this is the exposure. And then we let y be the second categorical variable of interest. Generally, we think of this as the outcome. So an example of this, and this is related to our NHANES final project data, is that our first variable x is gender. So this is a variable that's only captured gender as male or female, so it's dichotomous. And so that would be our first categorical variable of interest. And then we also have disease status, which is either yes, somebody has diabetes, or no, they don't have diabetes. So this would be the second categorical variable of interest. This would be our outcome. So then if you think to our final project, you will be looking at comparing a disease outcome or some health condition by male or female. So we have a categorical variable that we need to compare between two groups. Okay, so that's how we write the null hypothesis. However, we write the alternative hypothesis, or H sub 1, that there is an association between X and Y. So if we reject this null hypothesis and favor the alternative hypothesis, we would then say that there is an association between X and Y. Now, there's a lot of different ways that people write the null and alternative hypothesis for chi-square test. Like I said, the most easiest way is to say that there either is no association between X and Y, or that there is an association between X and Y. That's one way of saying the null and alternative hypothesis. However, if you look in the literature or take another stats course, you're likely to see other ways of writing this for a chi-square test. So other ways that people might write this is that there is not a relationship between X and Y, and the alternative would be that there is a relationship between X and Y. Or another way of saying that is that X and Y are independent, as compared to H1 would imply that X and Y are dependent. So this slide just shows you some other ways that you might see the null and alternative hypothesis written for chi-square if you look more in the literature or take another stats course. Okay, so this slide, I want to describe the kind of the bigger picture, the concept of what we're doing here. So what we're doing for a chi-square test is that we have our full sample, and then we're able to break our full sample up into group 1 and into group 2. Now, once we've captured group 1 and group 2, we probably split this up based off of some defining characteristic. So we could split this as male or females, or those who get an intervention and those who get the placebo. So we could split them into two groups based on some defining characteristic. Well, if we have group number 1, we can calculate the number of events, which is X sub 1. We have the sample size for that group. So using the number of events and the sample size for group 1, we could calculate the estimated proportion of that outcome in group 1. So if we were looking at the number of participants who have diabetes among men, we could calculate the estimated proportion of that outcome being diabetes in group 1, which would be men. So if we've done this for group number 1, we also could do this for group number 2, and we could calculate the same thing. So in the example of comparing diabetes status among men and women, the estimated proportion of the outcome would be the estimated proportion of those with diabetes in group 2, which would be among women. Okay, so the next step that we take when doing a hypothesis test is we need to figure out which test statistic that we're going to use. So we said that we're going to do a chi-square test, and that's indicated here in the right-hand side of the column. Now, I want to mention that there are specific rules or guidelines that you're supposed to use whenever doing a chi-square test. So for a chi-square test, you need the sample size to be sufficiently large for the different properties of the statistical test to work well. So that would be that the expected cell count is greater than 5 and that no cell has an expected count less than 1. Now, that's going to get into a little bit deeper concepts than we're going to cover in this class. So what I'm going to advise for this class is to always use a chi-square test. But I want to make you aware of what's going on here in the left-hand column. So say those sample size situations, the sample size isn't sufficiently large, then what we would do is use a Fisher's exact test, which is based off of different permutations to calculate the probability for the test. But for this class, we're going to focus on the right-hand column, which is using a chi-square test statistic. Now, in that last slide, we talked about cell counts or expected cell counts. So the cell counts are referring to the number of participants that fall into each of the 4 possible categories in a 2x2 table. So if we're looking at a dichotomous exposure and a dichotomous outcome variable, then each participant is either going to fall into one of these 4 cells, either into A, B, C, or D. So then what we want to do is enumerate how many people fall into each of these cells. So for example, let's say that we were looking at a dichotomous version of gender where we only have measured male and female, and we have diabetes status where we've only captured if the person has diabetes or if they don't have diabetes. Then what we would do is we would count how many people fall into female and have diabetes, female and don't have diabetes, male and have diabetes, male and don't have diabetes. So this is how we would construct a 2x2 table. So the reason that we do this is that this helps us calculate the relative frequencies of our outcome of interest by our group category. So then what we could do is we could report the prevalence of diabetes by gender. So then among females, 5 out of 15, or 33%, have reported having diabetes. And then among males, 4 out of the 15, or 27%, have reported having diabetes. So then based off of these numbers, we see that the prevalence of diabetes is higher among women than it is among men in this study. Okay, so for this class, we're going to use R to help us with choosing the test statistic, constructing the decision rule, calculating the test statistic, and then calculating the p-value for the chi-square test. We're going to let R help us out with all of this. It can definitely be done by hand, but that's beyond the scope of this course. So then we are going to decide if we reject the null hypothesis based on comparing the p-value, which will be given to us in R, to the significance level. So remember, of our 5 steps for hypothesis testing, previously we've really focused on 5.1, where we compare a test statistic to a critical value. But now what we're going to do, since R gives us a p-value, we're going to compare a p-value to the significance level alpha. Remember, for this course, we've chosen the significance level, or alpha, to be 0.05. This is pretty common for a lot of different fields and is especially common for public health, research, and medical literature. So we'll stick with a significance level of 0.05. So we will always compare if our p-value is less than or greater than equal to 0.05. All right. So for comparing the p-value, we will use this to make our decisions of whether we reject the null hypothesis or fail to reject the null hypothesis. So we'll analyze our sample and run our test in R. And then if the p-value is less than 0.05, we're going to say that we reject the null hypothesis. That means that we favor the alternative hypothesis. And that means that we've shown that there is a significant change, a significant difference, or a significant association. And specifically for chi-square test, we'll say that that means that there is a significant association between the 2 variables. Now, something else that could happen is we could analyze our sample and get a p-value that's greater than or equal to 0.05. So we could, if this is the case, then we are going to fail to reject the null hypothesis. That means we favor the null hypothesis. Now remember, we're not saying that we accept the null hypothesis or that the null hypothesis is true. We're just going to say that we don't have enough evidence to reject the null hypothesis. So this means, in essence, that there's not a significant change, difference, or association. So for the chi-square test, we'll say that there is not an association. All right, so then once we've have our p-value and we've compared it, we'll either reject the null hypothesis or we'll fail to reject the null hypothesis. So for scenario number 1, where we reject the null hypothesis, we'll report two different conclusions. We're first going to state that we reject the null hypothesis and favor the alternative hypothesis. And then the next thing that we're going to say is that we have enough evidence at alpha level of 0.05 to show that there is an association between variable 1 and variable 2. And then you'll replace what's in these brackets with the first variable of interest and the second variable of interest. So in the example I use from NHANES of gender and diabetes, we would say that we have enough evidence at alpha level 0.05 to show that there is an association between diabetes and gender. Okay, the other thing that could happen is that we could fail to reject the null hypothesis, and then we'll use these templates as ways to make conclusions about our test. So if we fail to reject the null hypothesis, we'll state that we don't have enough evidence to reject the null hypothesis and favor the null hypothesis. We'll then say that we don't have enough evidence at alpha level 0.05 to show that there is an association between variable 1 and variable 2. So in the NHANES example of gender and diabetes, we would say that we do not have enough evidence at alpha of 0.05 to show that there is an association between gender and diabetes. All right, well, that may still be sounding a little abstract. So let's look at an example using NHANES data. And this is the example that we're going to have R help us conduct a chi-square test. So the NHANES data, this is a data set that contains information from individuals who participated in the National Health and Nutrition Examination Survey. We're going to use the 2017-2018 NHANES data to perform a chi-square test to compare proportions of the outcome between those with diabetes, or compare the proportion of those with diabetes as compared to those we're going to compare the proportion of those with diabetes in male versus female. So I want to make a quick note on this slide, and I'm going to annotate this really quickly, that this should be updated. I copied and pasted this from the t-test example. So here we're not going to use a 2-sample t-test. We're going to use a chi-square test. And then this is not going to help us compare the mean, it's going to help us compare the proportion. Ooh, this is quite challenging. Okay, well, we're comparing the proportion, and now we're looking at the proportion of diabetes, and we're comparing that by gender. All right, so that's what we're going to do in R. So then we have gender, which is a categorical variable, and it's dichotomous. It's either male or female. And we have the diabetes variable, which is dichotomous as well. The participant either answered yes or no when asked if they've been told they have diabetes. All right, so let's go ahead and do this in R. So I'm going to pull up Google Colab. Now, remember that you need to make sure that when you switch over to R to do this, if you're starting a new file, the easiest way to start an R script in Google Colab is to copy and paste this link into your browser. Now, I've already done that and started this new script. And so I already have a script running in R. One thing that you might do is go to Runtime up on the menu and then scroll down to change runtime type. Notice that runtime type here says R, so I should be good to go. The default for Google Colab is Python, so you need to make sure that this is running R, or else you're going to get errors. If you're having issues getting this to run in R, please see the previous videos that I've posted on this YouTube channel. One about how to start a script in R using Google Colab. And that video goes through a lot of troubleshooting. All right, so using R, the first thing that we're going to need to do is import our data into R. So I've done a more detailed version, a detailed video, explaining how to import data into R. So I'm going to go a little bit quicker through this step. But remember that we have the sample data. We're going to use read CSV to bring in this file called NHANES_DM. Now, for those of you doing the final project in my class, you're going to be assigned an NHANES data set, but what you're going to need to change is this part right here to make sure that it matches your file name. Okay, so once we have this, if we ran this right now, we would actually end up getting an error. And it says it can't open the file, no file or directory exists. If this error comes up, what you're going to need to do is go over to the left-hand side of the screen and click on this files icon. And we need to actually update the data. So the data should appear here in this folder. So to do that, we're going to go up to this page with the up arrow on it and click on that. Now, I don't know where this is going to point you to your computer, but you need to have your data set somewhere saved on your computer, because your laptop or the R code is going to need to be able to upload this to Google Colab. So once you have it downloaded, point this to the right direction. It might be in your downloads folder. If you have a file project folder going on, it might be in there as well. So you can upload this and hit open. This warning pops up to let you know that whenever you close your browser, the data is going to be cleared. So if you work on this project for a while, do some coding, and then close your browser and reopen it, come back later, you're going to need to re-upload the data like we just showed. Okay, so now that this file is showing up here in this left-hand column, we can go ahead and close that. And now we can rerun this import. And with the green check, it looks like it was all successful. We can do a quick check. We'll use the dim function. Not simple data, simple data. And we'll run this. Now, what this is telling me is that the dimensions of my data set are 30 by 5. So in this example data that I'm using, I only have 30 participants in my study. So I only have 30 rows in my CSV file. And I only have 5 columns. So this means I have 5 variables in my data set. Your numbers are going to be different from this. Your data sets for the final projects are anywhere in the 2,000 to 4,000 range. So this first number should be somewhere between 2,000 and 4,000. This number should be 6 because you have an additional variable in your data set that you'll be summarizing that I don't have in mind. Okay, so that's importing the data. Again, like I said, I have another video specifically for importing data that you can go and watch if you're having any issues here. So let's get back to what we were doing with the chi-square test. All right, so to conduct a chi-square test, I'm going to copy and paste some code in here. We're going to use the chi-square.test function to determine if there's an association between gender and our health condition of interest. So for my example data set, I'm using the DM data, which stands for diabetes. So I'm going to look at if there's an association between gender, comma, diabetes. And now this last option adds a continuity correction, which again is a little bit beyond the scope of this course. But for the best results, I would like you to specify correct is equal to false. So that's it. This is the only code that we need to run the chi-square test. And we just need to put gender here and diabetes here for me, or you need to replace this with your health condition of interest. All right, let's run that. I didn't get this error earlier when I ran this, but let's see if I can troubleshoot this really quickly. Okay, so I took a little bit of a pause to figure out where this error was coming from. And to be honest, I'm not really sure why, because I just commented this out, which I had exactly typed before, and then retyped it on the line before, and it worked. So I'm not really sure what the error was, but if you have an issue like that where it's giving you a warning, maybe just comment this out like I've done here. So add the pound sign and then retype it and run it, and it should work for you. If not, please let me know. Okay, so let's go back to the slides and we'll go through an explanation of this output from R. All right, so here's the output that we have from R, and I just copied and pasted the output here. So let's go through some of these components. So the first thing you may notice is that I got a warning message whenever I ran mine. So this will happen if you have small sample sizes. So my example data is much smaller than the project data sets that you'll be working with. The small sample size violates assumptions that we discussed on slide number 25 when we were talking about the cell sizes of the chi-square test. Now, it's unlikely that you will get this error whenever you're running yours, but if you do, you can still use these results and that will be acceptable for this class. But in the future, if you do this for another project and you get this warning, you may want to resort to a Fisher's exact test. So that's what the warning message is. Now, what we need to do from this output is pull out the p-value, because remember, we're going to compare the p-value to our alpha level to determine if we reject the null hypothesis or fail to reject the null hypothesis. So for this chi-square test, you'll notice here that we have our chi-square test statistic, we have the degrees of freedom, and then we have a resulting p-value. With this, we compare that to 0.05, and it's greater than 0.05. So we fail to reject the null hypothesis, and we favor the null. So that is, we do not have enough evidence at an alpha level of 0.05 to show that there is an association between gender and diabetes status. Now, if in your project you get a p-value that's less than 0.05, then you would end up rejecting the null hypothesis, and you would conclude that there is enough evidence to show that there's a significant association between gender and your health outcome. All right, so we mentioned with the chi-square test that it's helpful to have a 2x2 frequency table to help us compare the prevalence of diabetes between our group of interest, and we're looking at gender specifically. So this is the R code that we're going to use. Note here that whatever is indicated that this NHANES DM data set, you're going to need to change that to yours. And in the table, you're also going to need to change diabetes to whatever your health outcome is. So let's look at how to run this table in R. Okay, so we can create a new block of code, and I'll copy in the code for that. So we've already run our data and attached the variables. So we're able to just run this function called table of gender, comma, diabetes. So what this is going to do, we can run that. All right, let me see if the same thing, I think there may be a copy and pasting error that I'm having today. So let's see if I run gender by diabetes, just retype it, if I can run it and get the correct results. Sure enough, I typed the same exact thing and it worked. So maybe this is a good troubleshooting video as well. So you can do table of gender by diabetes. So now what we've done is we've enumerated where each participant in our study falls. So we had 10 females without diabetes. We had 5 females with diabetes. We had 11 males without diabetes, and we had 4 males with diabetes. So the next thing that we want to do is having these frequencies is the first step, but what we really would like to do is create some relative frequencies. We want to be able to compare the prevalence of diabetes among men or among females and males. So then the code that we're going to use for that, this may look similar to what we've done before. So we're going to calculate the relative frequency of diabetes among females. So to do that, that's going to be the number of females with diabetes, which we said is 5. And we're going to divide that by the total number of females, which would be 5 plus 10 gives us 15. The next thing that we want to do is calculate the relative frequency of diabetes among males. And so that's going to be the total number of males with diabetes, which is 4, divided by the total number of males, which is 4 plus 11. We got all of those values from our 2x2 table. Then we repeat this down here so that this is printed out for us. Okay, it looks like I'm going to have to retype all of this so that it works. And there we go. So from this calculation, now we have the relative frequency among females of diabetes and the relative frequency of diabetes among males. So this is how you would calculate this. If you're running this yourself, you might need to change, or you will need to change the numerator, which will be the number of males with your females with your health condition, divided by the total number of females in your study. And then you'll need to change this numerator. This is the number of males with your health condition divided by the total number of males. So those will give you the two relative frequencies. All right, so just kind of to summarize that, we can put that in the slides. So you can see that the table of gender by diabetes gives you a 2x2 frequency table. And then we can calculate the relative frequencies of diabetes among males and females. And so then a way that you might want to summarize that is just list what that means. So the prevalence of diabetes among females was 33%, and the prevalence of diabetes among males was 27%. So that's all the slides that I have prepared for you for chi-square. So in summary, we looked at the background behind a chi-square test of independence. We looked at the hypothesis testing steps for that. We talked about how we're going to use R to perform a lot of these calculations for us. And we're going to pull the p-value from R and compare that to our significance level. So we looked in R how to calculate a chi-square hypothesis test. Then we finished by showing how to construct a 2x2 table and how to calculate the relative frequencies based on that 2x2 table. I hope this helps as you're working on your final project. If you have any questions about this video, please let me know.